Hello, my name is Santiago Martinez, and today we're going to be going over exam 3, seventh problem. It's a 4-part exam, and it says solve for x and check for any extraneous solutions. So remember, extraneous solutions is when we are presented with a negative value with a log, not so much an exponent or an exponential function. It really comes down to when it's a log and we have a negative or a zero output. So that's very important to note. And we will see a couple examples of this here. So let's start with part A. So A is going to be 4 raised to the 2x plus 1 is equal to 1 over 64. All right, right away, what can we do to get things moving? What I would like to do is, I know 64 is going to be a cube number, so, and it happens to be 4 as well, so that's exactly what we want. So try to play with a bunch of different options, right? So right away, I'm going to see 4, 2x plus 1. We're going to rewrite this in the property of 64 to negative 1 to the negative 1. Nice. What can we do now? We can take the exact same thing I told you about, of this being, of 64 being 4 cubed. So let's write that to our next step. So we have 4 squared x plus 1 is going to be 4 cubed raised to the negative 1. Amazing. So now what can we do? Well, I see that we have the same base, so we can actually take log base 4. In fact, we don't even have to do that, but first we can actually distribute this, and we should get 4 2x plus 1 is equal to 4 to negative 3. Make it a little simple. We can remember the simple terms of exponents, where if we have a to the n and b, or excuse me, a to the m, this simply becomes m plus m, right? This is the same logic here. Since we both have 4 and 4, it's basically drops down to 2x plus 1 equal to negative 3. Based off this property right here. Now we just solve like normal. So we minus 3 to this side, or excuse me, we're solving for x, so we would minus 1, so we should have 2x is equal to negative 4. Divide by 2, x is equal to negative 2. Pretty simple. This can be negative because it's an exponential function, and that's perfectly fine to be negative. Alrighty, let's move to part B. We'll change colors. Part B is e to the 2x plus 4e to the x is equal to 32. So right off the bat, I know in my head this is going to be a factoring problem, right? We can see the basic setup of a factoring problem, but let's separate our terms, right? So we should have 2, let's do e to the x squared, plus, we'll separate this term, 4 to e to the x is equal to 32. Beautiful. We'll make the notation of let e to the x equal u, and we should get u squared plus 4u equals 32. Now we'll subtract 32 to get 0 on one side, so we should have u squared, excuse me, plus 4u minus 32 equals 0. We're going to use A times C method, which is going to give us 1 times negative 32. Excuse me. And we should get negative 32. Right off the bat, what values are going to give us 4? And this is a relatively easy one. We have 8 and 4. We want it to be positive 4, so we'll have 8 times negative 4 will give us negative 32, and 8 plus negative 4 will give us 4. So we're going to rewrite that in those terms. We're going to write u squared minus minus 8u plus 4u minus 32 equals 0. Nice. So now we're just factoring like normal, right? So here we could take out a u, and we should end up with u minus 8. And then in this situation, I say let's take out a 4, right? And we should have u minus 8. That's all going to equal 0. And then we set it up in its final form, which is going to be u minus 8 times u minus 4 equals 0. And just like a normal equation, we will solve for these. But now we can plug in our values. But first, let's actually solve. So we have 8 is equal, u minus 8, so u is going to be equal to 8. And remember, we have e to the x is going to be equal to 8. And, oh, this should actually be, hold on, I apologize, I messed up my math. Yes, this is where I messed up my math. This is going to be a plus and a plus. And then if we wanted to get negative 32, we'll take out a negative 4. So yes, and this would be a plus and a plus. There we go. That's our mistake. My apologies for that. Make sure you remember your signs. So then this would mean negative 8, meaning e to the x is negative 8. And the reason why we cannot do this is because we can't take a log of a negative number. So the way we would solve this is we would take ln of e to the x to separate x, but we cannot take ln of a negative value because that falls under the log value. So this is going to not count and be labeled as extraneous. But we have another problem that we can work with. So we have u minus 4 equals 0 plus 4. That will give us u is equal to 4, which is also going to be e to the x is equal to 4. So we'll take ln of both sides. And we should get x is equal to ln of 4. And that one works perfectly fine. Beautiful. Let's change colors one more time. We'll change it 2 more times, actually, excuse me. Let's work through, and we'll shrink these as well, just to give us a little more room to play with. Smooth this up here. Beautiful. Now, we'll do problem C, which is going to be log of 4x minus 3 equals 2. Pretty straightforward problem. I'm gonna grab a quick drink of water. So what can we do in a situation like this? Well, anytime if we want to get rid of a log, we can always raise it to a power of its base, right? So if this was 2, we raise it to 2. But since this is the natural log, we can take 10 to the log of 4x minus 3 is equal to 10 to the 2. So you have to raise both sides. Then in result, we'll get 4x minus 3 is equal to 100. And then we would solve normally. So we'll minus 3, so we should get 4, or plus 3, 4x is equal to 103. And then divide by 4, x is equal to 103 over 4, which works perfectly fine. Amazing. That one was pretty straightforward. Now let's go to our last problem of this video, which will be D. these relatively simple, so we'll do log of 2 of x plus 2 plus log of 2 of x minus 3 equals, we're gonna move this over a little bit. This is a very long problem, but not to fret, we'll get it solved. Move it down here as well to give us some more room. Equals log 2 of 18 minus log 2 of 3. So an important thing to remember is that when we're dealing with logs, we cannot take anything or raise anything when we have two logs on each side. We have to have log only on one side of our equation in order to do something like this. One log on each side of our equations. So we'll just use our simple properties, right? Right here, we know we can use the property of addition turns into multiplication or vice versa. So we should have log base 2 of x plus 2 times x minus 3 is equal, and we have subtraction here, so we can write this as log base 2 of first value always over 18 over 3. Beautiful. So now what we could do is we do have to evaluate this real quick. So this is just distributing. So we'll have log base 2 of x squared minus 3x plus 2x minus 6. We'll combine like terms after we write the other side of the equation. It's log base 2. Be careful with writing the way you write your powers or your bases. And we'll get log base 2 of x squared minus x minus 6 equals log base 2 of 18 over 3. A very simple problem. Now we can just raise everything to the power of 2. So we should get this. Absolutely amazing. So we should then end up with this is equal to 18 over 3. That obviously simplifies to x squared minus x minus 6 is going to be 6. Subtract 6. We should get x squared minus x minus 12 equals to 0. What does this look like? Another factoring. So we'll factor that real quick. Again, move up just a tiny bit, just to here, right about there should do it. We'll do a times c, which is 12, and has to equal 1. So this would just be 3 and 4, right? But we'll show it right here. A times c, which is going to be 1 times 12. Or negative 12, and that will give us negative 12. And we'll split that off to 3 and 4, because 3 times 4 is 12, and it has to equal 1. So it has to be positive 1, so we do negative 3, because negative 3 plus 4 would be 1. So let's pair this up. So we'll do x squared minus, let's try 3x right here, plus 4x minus 12 equals 0. We'll take out an x here. We should have x minus 3 Then here we'll take out a 4. We'll have x minus 3 equals 0. Rewrite it in terms of x plus 4 and x minus 3 equals 0. Now we have to solve for both sides. So x plus 4 equals 0. We're going to minus 4. X is equal to negative 4. Can't do that because it's a log, so extraneous. And then here we'll have x minus 3 equal to 0. We're going to add 3. X is equal to 3. This one works. Absolutely amazing. And that is problem 7 of exam 3. Thank you so much.